Logarithmic applications, algebra 2 trigonometry regions. So using logarithms to solve for exponents, we have a special formula. This formula is sometimes referred to as the change of base formula. So if you ever hear a problem, refer to that. They are talking about this. Basically, the notation we have of base exponent equals answer. Let's pick a simple example here. 2 to the third equals 8. So 2 to the third equals 8. We know that our base here is 2, our exponent is 3, and our answer for 2 to the third is certainly 8. Well, say we didn't know this. Say we have a problem like 2 to the what equals 8. 2 to the x equals 8. Or in log form, that would be log base 2 of 8 equals x. You know, these are saying the same thing. And we can convert back and forth between the two of them. But notice that here, my variable is my exponent, and then the same thing here. It's logs equal exponent. So my variable is my exponent. If I'm solving for an exponent, I have a formula I can use. Now, we have learned in the past that something like this, I could, create a common base and set my exponents equal to each other, but that's not always possible. Like if I said, 2 to the what equals 17. 2 to the what equals 17. 17 is not a power of 2. It's going to be some decimal. So there's no way for me to do this by getting a common base or anything like that. So you have to use logarithms. And what you can do is exactly this. You can solve for your exponent by having your exponent equal. So in the case of 2 to the x equals 17, that would convert to x equals log answer over log base. And I've said many times that the base is always on the bottom because it's on the bottom of the exponent and it's on the bottom of the log. Well, now it's on the bottom of this formula too. So always remember base is on the bottom. So what you could do here is you could solve for x by doing log answer, which is 17, divided by log of the base is 2. And our calculator can do this algebra for us. Log 17 divided by log 2. Now before we do that, let's kind of think about what it might be. Well, for this problem, we do know that 3 is our answer. 2 to the third equals 8. Well, 2 to the third is 8, and 2 to the fourth is 16, which is pretty close to 17, and 17 is just one more than that. So I'm guessing it's 4 point, a very small decimal, probably close to 4.1. All right, because 2 to the fourth is 16. Now 2 to the fifth is 32. We're not quite there. So it's a little over 4. But let's take a look. So all we have to do is type in, we have a log button. Hold on one. Sorry about that announcement. Came on a loudspeaker, so I just paused it for a quick second. So anyways, we have a log button over on the left side of our calculator here. It says log. So if we type in log 17, now notice that it opened a set of parentheses for us. So it's really important here that before I divide, I have to close the parentheses, then divide, and then do a new log for 2. And close those parentheses also. If you don't close the parenthesis before you divide, you're going to get something weird. And the answer is 4.087, pretty close to 4.1. And these problems typically then say things like, round to the nearest, tenths or hundredths or something like that. So the nearest tenth, the answer would be 4.1. Okay, it's approximately 4.1. All right, so that's what we're going to do here. Let's look at problem here, number 2. So 3 to the x equals 2187. Is this a power of 3? I have no idea. If it is, I don't know what it is. So I can solve for it by simply doing x equals, again, I'll write this over here, exponent equals log answer over log base. And so the answer here is 2187. So log 2187 divided by my log of the base of my exponent is 3. So I'm going to simply just type this into my calculator, see what I get. Log 2187, close, divide, log 3. And it is a power. It's 7. So it works out. That x equals exactly 7. 3 to the 7th is 2187. So this formula is very useful for solving for exponents. In the previous video, we were working with some exponential uh, word problems type of equations like these. And sorry about that. And we weren't really doing any logs then, but I kind of told you that we're going to start to use logs for these problems. So what we see here is the number of bacteria present in a petri dish can be modeled by the function n equals 50e to the 3t. So this is one of those PERT formulas where n is kind of our answer. P, or our principal, would be 50. E is E. 3t, 3 is kind of our rate, I guess, in the sense here. And t is time. So they're giving us this stuff plugged in already. 50 is going to stay 50. E is going to stay E. 3 is going to stay 3. The only thing we don't have here is t and n. So they tell us n is the number of bacteria present after t hours. So n is the answer after t hours. Using this model determines the nearest hundredth, the number of hours it will take for n to reach 30,700. So this is different than the previous video, because in the previous video, it was like, how many bacteria will there be in 6 hours? And so we plugged in 6 for t, typed into our calculator, and got n. What we're doing here now is we are solving for n. I'm sorry, we're solving for t given n. So it's a little bit different. So we want to know, when will n reach 30,700? So I'm going to substitute this value in for n. And that will give me 30,700 equals 50e to the 3t. And the one thing I don't have, the thing I'm solving for, is time. So it determines the nearest number of hours, and they tell us t is the time in hours. So I need to solve this, and what I'm going to do is I'm going to use this concept of, I could solve for an exponent by doing log answer divided by log base. Now, before we do that, my exponent here is 3t. 3t is the exponent. And the base of that exponent is e. This is the base. This 50 here is not part of the base, because this is 50 times e to the 3t. 50 is not being raised to the 3t like e is. So your principal for these problems, the 50, that needs to be removed first with just basic old algebra before you do any type of logarithm. So you need to isolate the base and exponent before you do any logs. So this is 50 times e to the 3t. So to remove it, I'm going to simply divide 50 on both sides. And so divide this by 50. And again, my calculator is going to be very handy. And so 30,700 divided by 50 is 614. So 614 equals e to the 3t. Now that I'm down to a base of e, an exponent of 3t, and an answer of 614, now I can use my formula of an exponent equals log a divided by log b. Log answer divided by log base. So my exponent, 3t, will be my log of 614, is the answer. That's a little sloppy. Divided by log of my base, which is e. Let's move that over a little bit. And simply type this in. So let me clear, get a fresh screen. Log 614, close parentheses, divide log e. And you could actually use natural logs here, but I don't mind using log base, log e. So 3t equals 6.419999, so on, so on. 6.4199 and a bunch of other stuff. But I want t, so then I got to finally divide by 3 in the end. And I'll get a final answer for t, and we want to the nearest hundredth. And you're going to have decimals for these problems. That's normal. So divide by 3 to get the t alone. Nearest hundredths, tens, hundredths, so that'd be 2.14 is t. 2.14. So that's basically it for these problems. Just want to pick ahead. No, we'll save that one for class. You need to simply set your equation up, they'll tell you what they want it to equal and solve for that variable t. And you have to isolate the base and exponent first, so dividing that number over. And then once you get it down to this level here of just a base and exponent answer, you can do your division of logs to solve for your exponents, and then if your exponent is t, you're done. But if it's something like 3t or more complicated, then maybe you got to do a little extra algebra like we did in this case. Don't forget to round properly.